So this is 8.4b. Okay, we're going to be solving quadratic rational equations, which again, we've already kind of been introduced last class with 8.4a. We're just going to be doing a few more examples that are just a little bit more difficult. Okay? For example 1, what I want you to do is I want you to actually change this. We're going to change this to an x minus 2 on the bottom, and we're going to make this 13 and this 4x positive. Okay, that's actually applying a rule. And I know we learned this rule already, but it was the a minus b over b minus a rule became -1. Do you guys remember that? We kind of talked about it, but okay. Well, we're going to switch the problem because that won't be on the test, so we're just going to go from here. So this is what we're dealing with, okay? 3x over x minus 2 minus 4 equals 13 plus 4x over x minus 2, okay? So think back to last class. How do I start something that looks like this? I need to look at the denominators, okay? We see that the first one is x minus 2, right? What about the second one? 1, and the third one. Okay, so what will x minus 2, 1, and x minus 2 all go into? Nope. X minus 2 is a binomial, 1 is a monomial, right? Which we technically don't even have to write the 1. So x minus 2 and x minus 2, what will they both go into? X minus 2, yeah, yep, it's a binomial. Let's wake up. Okay, so that's my common denominator right there. So it's going to go 1, 2, 3 places because I have 3 fractions here. Okay, again, it's a binomial, so I just need to write my monomials times my binomials. I don't need to cross anything off. I don't need to distribute anything out. I just multiply by the numerator and I keep the same denominator on each term. So the next one is minus 4 times x minus 2 over 1 equals, and then I've got 2 binomials, which again, we keep them separate. We don't distribute, don't do more work than you need to. So again, multiply by the numerator, keep the same denominator for each term. Are you with me? Coming back to us. Okay, cool. So now we look at the first term. Do we see anything that's going to happen there? Yep, same binomials cancel out. Okay, so we're left with just 3x minus, what about that term? Yeah, we're going to distribute, okay? There's nothing that's going to cancel out, so we need to go ahead and get our terms. So -4 times x would be -4x, and -4 times -2 plus 8. Perfect. And then the last term, what's going to happen here? Cancel those out, and we're left with perfect. There we go. Now we just solve it, right? Okay, go ahead and solve it from there. Okay, how'd you solve this? Okay, what do those become? -1x. Okay, next step. Add the 1x over, I like it. So we end up with 8 equals 13 plus 5x. Now what? Good, Jaden. 8 minus 13. -5 equals 5x. And what's my final answer going to be? X equals -1. Last but not least, I go and I check for extraneous solutions. So I go plug in a -1 everywhere where there's an x in the denominator. And I see both of those denominators end up being -3, and that's okay. So we're good to go on that one. This one works. Okay? Questions on that? Okay, example 2. I want you to just find the common denominator. Something all those denominators are going to go into. Okay, so we're going to find the common denominator here. We notice that our denominators are monomials or binomials. Monomials, so they don't need to be factored, right? Yeah, so we just need to find a monomial that all of those monomials will go into. So think about it. What do we think? Okay, all the numbers will go into 6, right? 6, 6, and 2 will all go into 6. You also could have used something bigger like 12, okay? Because they do all go into that. And then what about my variable? Nope, not x. X squared, yx squared, and not x.
Because x squared is the biggest, x.
Yep.
And the small one has to go into that.
You're right. Yep, x squared is the bigger of the two. X will go into x squared. Okay, x goes into x squared. X squared would not go into x, so that's why it's got to be the bigger one. Okay, good deal. So now, what do we do from here? We distribute how many times? 3 terms, right? Okay, so we multiply the monomials if possible, but if it's a binomial or a trinomial in this case, we just write it down. So for the first one, we got 6x squared being multiplied by this big thing. I'm not going to deal with that yet. I'm just going to multiply the tops and leave the same denominator. Keep my subtraction sign. Can I do 6x squared times 5? Since those are both monomials? Yeah, what is that? Not 35, 30x squared, good. Keep the same denominator. Keep my equal sign. 6x squared times 1. 6x squared over 2x. Any questions on how we got that far? Everybody good with that? Okay, so now we look at the first term. What's going to happen there? Yep, these are going to cancel, and we're going to be left with what? Perfect. Okay, 30x squared over 6x squared. What's going to happen there?
It's going to be divide x.
We are going to divide it, yeah.
We have to simplify.
I like the 5. I like 30 divided by 6. I like that that's 5, so minus 5.
It's still x squared?
Well, aren't those going to cancel?
Yeah.
Yeah, but they're going to cancel to nothing, right? There's nothing left. So it's just going to be -5. No x. Okay, but then on the right side, we'll start with the numbers. So 6 divided by 2 is? And then x squared over x. That one is going to have an x. Good. Okay, so this is where there's only going to be a few of these on the test, so it's not going to be a huge thing, but you do need to know how to do it. Okay, when we're left with x squareds in our answer, okay, that means we're going to have 2 answers when we do this, which means that we've got to move it to one side. Yep, you got it. Okay, so what I need to do is I need 0 on one side and I need everything else on the other. So I'm moving this 3x over and I'm going to combine my like terms. So I end up with x squared, 4x minus 3x is going to be 1x plus 1x, and then 3 minus 5, -2. Now you gotta do the what? X method. Woohoo! We love this. We're getting good at it. What goes on the top? What goes on the bottom? 2 things that multiply -2, add to 1. 2, negative 1. So my two factors are equals 0, and I'm almost done, okay? These aren't technically my answers though. They're both set equal to 0, so I need to break them apart. X plus 2 is 0, x minus 1 is 0, so x is going to be negative 2 and 1. Those are my two answers. And last but not least, I go plug those into those denominators. Well, those are all monomial terms, and none of them are going to be 0 if I plug in a negative 2 or a 1. So this one is also good.
That's the same exact problem.
Okay, thank you for stating that. Yep, these notes have a typo, so we are scratching out example 3, because again, it's the same, just as Zach told us. This is going to be the new example 3 that I want you to write down. And there will be one just like this on your test, so make sure we know how to solve it. You might want to put a star next to it. 1 over x plus 3 plus 2 over x equals negative 3 over x times x plus 3. Okay. Everybody got that down? Okay, so we notice in the denominators, we've got what going on? Monomials, binomials, or both? Both, okay? So what I want you to do, figure out what the common denominator is, and then go ahead and distribute it and simplify each term. Okay, so I'll give you about 2-3 minutes to do that. All right, guys, so listen up. We said, okay, if we have binomials in the denominator, we need all of them unless they repeat, right? We only need to write it once. If we have monomial terms, we need something big enough to where every monomial will go into it. So I'm going to look at monomials first. What are my two monomials here?
X, 2 over x.
X and x in the denominator. What will x and x both go into? X. Perfect. Okay. Binomial. What's the binomial? X plus 3, and it's the same, so I don't need to write it twice. I just need it once. This is my common denominator. X times x plus 3. That's my common denominator. So now it's going 1, 2, 3 places.
Now all the bottoms change to x plus 3.
They would, yeah, if we wanted to do that, but we're actually just going to multiply it to the top and then keep the same bottom. So for the first one, x times x plus 3 times 1 is just going to be, whoa. Yep, x times x plus 3, or 1x times x plus 3 over x plus 3. Keep the same denominator. And then on the second one, what are we going to write there? 2x, parentheses x plus 3, over x. Perfect. Equals what?
Negative 3x, x plus 3 over x.
Perfect. That's it. Now we simplify. Hardest part's done. So I look at my first term. What's going to happen there? And I'm left with 1x. Second term. What's going to cancel for the second term? Yep, just the x. Get rid of just the x. So it's 2 times x plus 3. Can that distribute?
Yeah.
Yep. So it would become perfect. And then the last term. Yep, cancel out the x and the x plus 3. So I'm just left with Negative 3, yep. So that's what I'm solving now. Any questions on how I did that?
No.
Are we okay with this? No, not yet. We have one more problem. Okay, what's gonna happen on the left?
Oh, so now you gotta combine my terms.
Yes.
Oh,
3x plus 6 equals negative 3. Thank you.
my bad. I thought it was right.
Now? Okay. So 3x equals.
You get 9. And then you divide it into x equals negative 3.
Perfect. So that's my answer, right? Okay. What'd you say? Someone say nuh-uh?
You say no.
Okay, but what about if I go plug this back in to here
You should do that.
or here?
Don't do it.
Don't do it.
What is negative 3 plus 3?
Nothing.
Nothing. Can we have nothing on the denominator?
Yes.
No. So technically this is a no solution. I did all that work and I found an answer that worked and it didn't actually work. Haha. Sometimes life's like that, unfortunately. So this one is a no solution. When you type these in on Delta Math, you literally just hit the enter sign. You don't type anything in, and that's how you type in a no solution on there. Okay? You don't have to write anything.
We just wasted our time.
Yes. It would be
Why would we do
probably like a half point. Yeah. Okay. You need a spaceship.
Hear me out.
Okay. Tell us why you need a spaceship, Timmy.
Listen, there's some pretty cool ideas.
Know that this is recording right now, so everybody at home can hear why you need a spaceship.
Alright.
Okay.
They can hear us too. I don't care.
Okay, keep it appropriate.
So if I had a spaceship, I could literally, like, go to every single planet, okay, gather resources, come back to Earth, sell them, and I'd be the richest person on Earth.
What resources are those other planets gonna have, though, that
Dude,
you...
I don't know. Martian pants.
What?
Martian pants.
They're gonna have Martian pants?
Gee, you think aliens don't go shopping?
Okay.
You're crazy.
No one's gonna tell you that you have Mars rock.
Dude, if they watch me leave the orbit from Earth, it's gonna be televised, dude. I'm gonna be the first person to do this.
Okay.
So if they watch me leave, what do you think I was doing in the ship the whole time?
Timmy, I hope that happens just for you.
Or like maybe I could just make my own clothes in the ship and just come back and like sit outside the Earth.
You're gonna make your own
for
spaceship?
like 5 years, come back in, it's like with clothes I made by myself, and that's how I find alien clothes.
How do you operate a spaceship?
Nice theory, bud.
Dream big. Dream big. All right, let's finish this last problem. It's taken us a really long time to do 4 problems.
Well, then we had to stop those about why you needed a spaceship.
And I believe him, he does need one, okay? But let's talk about it more after this. Okay, example 4. Are all of those denominators factored?
Nope.
No, so you need to factor them. You need to find the common denominator, and then you need to do exactly what we did in example 3. Ready, set, go. We'll go over it in about 4 minutes. Who at least thinks that they factored this one right for the denominators? Who's having a Monday? Raise your hand. Okay. No more hands there. Okay, let's factor that first denominator. I know it's Monday, but we can do it. We always check for a what? When we're factoring. When we're factoring, Timmy, what do we check for? UCF. Does this have one?
Yeah.
A squared and negative 6a? What do they both have?
6.
No. They both have an a. But when I take out the a, what's going to be left? A squared divided by a is? No. A. Negative 6a divided by a. So a minus 6. There we go. Now do we see what the common denominator is going to be? Yeah, what? You don't see it? A times A minus 6. Look up here. Okay, we had binomial. That was the same monomial. We have the exact same thing here. Our monomial is A. Our binomial is A minus 6. So now we're going 1, 2, 3. For the first one, tell me what I'm going to write on the top. I'm not distributing anything, I'm just multiplying. So I keep all my binomials separated in parentheses, I keep my monomials in the front. So A times A minus 6 times A plus 3. How am I going to write that? Come on. The monomial term is what? A. And the binomials are?
A minus 6.
Thank you. And what's on the bottom? A times A minus 6. Second one. Monomials are what? A times 6A, which is 6A squared times the binomials, which are just A minus 6, over,
A minus 6.
thank you, plus what?
2A. And then 8 times A minus 6.
Over,
A.
perfect. Is anyone still confused on how we got here?
There's so many A's.
There's a lot of A's, but we're going to get rid of some. So the first fraction, what can we do there? The A and the A minus 6. Second fraction,
Cancel out the A minus 6. So you use that 6A squared.
and the third,
Cancel out the A's.
just the A's. So this 2 can be distributed, right? And that will be
2.
perfect. 2A minus 12. Now what? Get everything to one side. So I'm going to move over what? I'm not going to add 3. Subtract 3. What else should I subtract? The A. So this ends up being 0 equals
6A squared. Plus A.
minus
15.
perfect. Okay. Now what do we do?
Oh, freaking letter.
X factor, what goes on top? No.
Oh,
Negative 90. Thank you. 6 times negative 15. Yep. And then the bottom?
I just can't do that.
1. So two things that are going to multiply to negative 90 and add to positive 1. What do we think? Just right over there.
Negative 9 and 10.
Negative 9 and 10. Good. Okay. Will our shortcut work on this one? Our shortcut, these were just the 2 factors that we used. When could we do that? When the leading term was 1. Is that a 1? No, it's a 6. So we got to go back to the old way of X method for this problem and this problem only, okay? We keep our first term. We just found our 2 new middle terms, negative 9A and 10A. And we keep our last term. We group the first 2 terms. Plus sign. We group the second 2 terms. First 2 terms, 6A squared and negative 9A. What's the GCF? 3a, and when I take that out, what's going to be left? 2a minus 3. 10a and 15 both have a. And what's going to be left? 2a minus 3. So my final two factors are 3a and 2a minus 3. Lastly, we've got to break them apart. So 3a plus 5 equals 0, 2a minus 3 equals 0. On the first one, we would,
Subtract 5,
and then divide by,
3,
so it'd just be negative 5/3. And on the second one,
add 3,
and then divide by,
2,
so it'd be
8 equals 3.
3/2. And then we go plug them back in. They both work though. Okay, that one was a lot more work. Look at that. But we did it, right? We did do it, okay? It is going to be on the test. There won't be very many, okay? But you do need to study, and try to learn how to do that. Don't throw anything. Okay, I know it's Monday, but it's out of the way. We're done with this unit. This unit is over, okay? Review day Wednesday, test on Friday. Woohoo!